Hey, welcome back to Math with Patrick. Today is January 17th, and we're solving the 17th problem from this Daily Epsilon calendar. All right, let's try it out. As always, the answer is right up here in the corner, but it's up to us to figure out why 17 makes sense. Find the size of the interval that satisfies this inequality. Okay, so what I'm getting from this is that there's a lot of different values for x that I could pick that make this inequality true. Whatever I have on the left side here must be less than or equal to 10. And I'm going to express my answer as an interval. That means starting at some number, say like -3, and going up to, I don't know, a higher number, like 6. And I'm going to write this interval using, well, interval notation. These brackets mean that I do want to include the numbers -3 and 6. And if I happened to use parentheses instead, this is still an interval. It still describes all the numbers between -3 and 6, but it just doesn't include these ones. So it stops like right before 6 and doesn't actually get there. Anyways, this interval, if I'm using brackets here, so I'm including -3 and 6, this has a size of 9. You could kind of think about this on a number line. If I have 6 and -3, well, I would need to count up 9 times to get to 6. So ultimately, when I figure out an interval that makes sense for this problem, I'm hoping to see that these two numbers, the lower one and the upper one, are 17 apart. Oh, and one last thing to mention about finding the size of an interval. A quick mathy way to do it is just take the higher number and subtract the lower number. And if I subtract a negative, it's like the same thing as just adding. And so here's that 9 that I was talking about earlier. It's that size or width of this interval. All right, I rewrote the inequality up here. And you can treat inequalities kind of like how you would treat equations, as in you can do these opposite operation steps to try to simplify or rename or essentially move around stuff in your inequality and try to make more sense of it afterwards. So I'm allowed to add 7 to both of these sides, and I still get the absolute value of 2x minus 5 is less than or equal to 17. All right. A little suspicious that a 17 already showed up, but I don't yet trust that I could just circle this and call it good. I feel like I need to get an interval, some lower number and higher number, before I start just claiming that this is the 17, this is my answer. I don't think so yet. All right. The way that absolute value bars work is that they take whatever's on the inside and make it positive. That's one way to think about it. Alternatively, you could think about it as the distance to 0. So -3 needs 3 hops to get back to 0, so its absolute value is 3. And what I'm seeing here is that I have some number, don't really know what's in here yet. I take the absolute value of it, and it's less than 17. So this tells me that I could take 2x minus 5, and it could be at most 17, and it could be at least -17. And again, that's because if I pretend that this stuff, this 2x minus 5, is equal to -17, and I take its absolute value, again, that's equal to 17, its distance away from 0 is 17, and this would satisfy my inequality because 17 is equal to 17. So breaking up the absolute value bars, I'm able to get this double inequality. And it still kind of works the same way as equations. I can still simplify by adding and subtracting to all the parts in my inequality. The one thing to watch out for is that if you happen to multiply or divide by a negative number, it flips your inequality signs. If you want to know why, well, maybe that would be another video. But I think I'm not going to be dividing by any negative numbers, so it doesn't actually matter here. I'll add 5 to all of them, so I'll write that out. I'll say +5, +5, and +5. And the reason why is in the middle, this -5 and +5 cancel out, so I'll just get a 2x. That should be less than or equal to 22. And it should be greater than or equal to -12. Finally, I can divide all of these by 2. And I should write out all my steps so I can be super thorough. And I see in the middle, 2x divided by 2 is just an x. 22 divided by 2 is 11. And negative 12 divided by 2 is negative 6. So this is my interval right here. And earlier I said you could do the higher value minus your lower value and get the size. And 11 minus negative 6, that's the same as 11 plus 6. And here is my 17 after all. Great. So I found the interval, and I've shown that its size, or its width, the distance from low to high, that's a 17. Looks like I'm all done with this problem, so that's it for today. I'll see you in the next one. Thanks for coming along and working on this problem with me. Bye. Well, I guess maybe you could stick around a little bit longer if you want. I want to make sure that my interval makes sense for my inequality, and I want to try plugging in some numbers in my interval and outside of the interval just to make sense or make sure that it does make sense. So let's just double check it. I want to pick a value inside of my interval, plug it in here for the x, and make sure that this inequality sign is happy, or like it makes sense. And an easy number to pick that's between negative 6 and 11 is just 0. So if I try x equals 0, I'm inside of this interval. And so when I plug it in right here for my x, I should get an inequality that does make sense. So I should evaluate the stuff on the inside first. 2 times 0 is 0. And then negative 5, 0 minus 5 is negative 5. So I'll write that down first. Then the absolute value of negative 5 is positive 5. And I know that 5 minus 7 is negative 2. So yes, negative 2 is less than 10, so it works. And now I want to plug in a number outside of the interval just to show that it doesn't work. Maybe this time I'll pick 12 because that's just a little bit higher than 11. If I stick in a 12 right here, I'll get 12 times 2 minus 5. Absolute value that. Then take away a 7. And I'm hoping to find an inequality that doesn't make sense because currently my input is outside of my interval. So 24 minus 5 is 19. I'll do the minus 7. And the absolute value of 19 is still just going to be 19. Then when I do 19 minus 7, I get 12. And this is a weird result. 12 isn't less than 10. So this inequality doesn't make sense, which is actually totally fine because the input number that I did was not in my interval to begin with. Well, I hope that last little bit gives you just that much more trust that my interval is the one that satisfies that inequality. And then, 11 minus negative 6 gave us 17. That's today's date. We're all done. All right. Bye for realsies this time. I'll see you tomorrow, though.